Hokie dokie. In this problem, they give us some information about some fruit tree orchard, and the biggest thing is I would skip to the last sentence or question where they ask us to find the max or the min or the something. It's always the something max or the min of the yield, something known as the yield. So what we're going to do is set up a yield equation. I'll give you the format for the yield equation that you will use every time in this problem. So the first part of the yield equation is an expression representing the number of trees. The second is an expression representing the pounds per tree. So starting with y, or yield, we'll say the number of trees. They tell us it starts at 100, and they tell us we cannot remove any already planted trees. So really we are only planting additional trees or adding additional trees, so T, right? And so looks a little whatever. All right. Okay, so now we want pounds per tree. So if you had to follow kind of the format, or not the format, but use the last one kind of as a reference to how I set this one up, we can maybe assume that the next one is going to start with 264 pounds per tree. And then they tell us it's decreasing by 2 for every additional tree planted. So minus 2t. All right. So this, just like that, is our yield equation. This is the equation or the function we want to find a maximum of. So we want to find its derivative and set it equal to 0 and solve for t, and then we'll talk about what to do from there. So the first thing is, before we take its derivative, I would say let's distribute these values to save us from doing the product rule when we find the derivative. So 100 times 264, I guess we could do that by hand. What is that? 264 with 2 zeros. All right, not bad. And then plus 264t, we'll have a minus 200t and a minus 2t squared. So now, focusing in on this, let's rearrange some terms. We'll put t squared first. We'll combine these like terms to get 64t, and then add the constant. Now that we have the yield in a somewhat simplified form, we want to find its derivative, y prime. So y prime is negative 4t plus 64. Constant goes to 0. And now we set the derivative equal to 0 because we're finding the critical point. We're finding the t value for which the yield could be maximized. So what should we do? Let's add the 4t to the right side, then divide by 4. 64 divided by 4 is 16. And so we find that t is 16. So you might think 16 trees. No, but t is the number of additional trees. So t equals 16. We have 16 additional trees on top of what we already had. So in some versions of this problem, they will ask for number of trees in the answer choices. In another version of the problem, they'll ask for pounds per tree in the answer choices. So depending on which thing they're asking for, tells us which half of this yield equation we plug the t value into. So in this case, we'll plug this 16 into the number of trees expression that we found at the start, and that was 100 plus t. So 116 trees is our final answer. All right, so let's give that another go with a version where they ask for pounds per tree. So setting it up in the same way, starting with number of trees plus t. It's always plus t for number of trees, but it's the second expression that might change depending on how many pounds it's decreasing by for each additional tree planted. But same exact setup, same distribution process here. So let's distribute everything, FOIL everything out. I'll just leave 50 times 276 like this, since it really doesn't play a role in the long run. We have 276t, we have 50 times -2, so minus 100t, and then minus 2t squared. Rearranging, we have -2t squared plus 176t plus some constant. It doesn't really matter. Now that we have it simplified, we find its derivative. We get -4t plus 176. Add 4t, divide by 4. Let's see, can we do that? 45 minus 1, I think it's 44. I'm going to go with our gut here. So 44 for t. And because, again, they're asking for pounds per tree, we want to plug it into the pounds per tree expression that we found at the start. So 276 minus 2 times the t value we just found. So 276 minus 88, we get, what is that? How do we subtract by hand? We'll do 16, so we get 8. That's a 6 now. And then 6, so we have to do the same thing. So 16 minus 8 is 8. 188. Huh? Did we do that right? Let's hope we didn't embarrass ourselves. Oh, thank goodness. Okay. I just like to challenge myself sometimes and work it out by hand. But, of course, feel free to use a calculator or Excel, whatever. All right. I hope this helps. This is the tree yield orchard max problem. I'm all over the place right now, but if you have any questions, please let me know.